Hi guys, welcome back to the stream. So today we are going to solve the problem of the day, find minimum in rotated sorted array 2. So basically this is a hard question. The question states that the array is rotated and you need to find the minimum in the element. So you can directly solve using uh, linear search, which gives us a time complexity of O of n. So what you can directly do is we'll take a minimum variable. We'll run a loop from 0 to n. Then declare that is not start length. Then find the min value from the array which they have given. This min comma comes of I, and you can directly return the min. I solve this question. I think you can submit it. I don't think it is an optimal solution. So the optimal solution would be O of log n. So, so the thing is, here we need to reduce the number of comparisons of we are performing. For example, we are performing O of n operations. So that's not the case. We need to reduce the number of comparisons which we are doing now. So for this, what we can use? So yesterday I told you that if a array is given and it is sorted and you need to find minimum in it, so we can, and the time complexity is O of n. So we can directly find the algorithm, that is binary search algorithm. So for that, I'll take you to the iPad screen so that I'll be explaining you in the proper way by using the try run and all. So I think you can see the iPad screen as well. So the previously, how we are solving this question. For example, we are having 1, 2, 3, 4, 5, and we are directly searching all the values with min, and we are returning directly and returning the min. But it should not be performed like this. It should be O of log n. That is, we need to use binary search algorithm here. Binary search. So how we can do that? So basically binary search, you know that it will be finding using the two pointers, that is low and high, and finding the mid value. And if the target is what we are looking is less, then we will be moving to high equal to mid minus 1. And if the target is more, we'll be moving to low equal to mid plus 1. In a similar way, we need to solve this question. So I think you remember the question where we got yesterday, that is find minimum in rotated sorted array. But the main difference for first and second is nothing but find min rotated sorted array. So there are two questions, that is find minimum in rotated sorted array 1 and find minimum in rotated sorted array 2. So in the first question, we have used binary search. In this also you can use directly binary search, but there is one hack you need to apply. So if you okay, I'll go to the laptop screen. So if you check the question here, the array is sorted in ascending order between 1 to n, and they have given one thing, that is given the sorted array nums that may contain duplicates. So if there are duplicates, There might be a case where low, mid, and high will be duplicates. So in this case, we need to handle this edge case. If you handle this edge case, we can directly solve this. So for this, what you can do is, we're removing everything now. We'll take an example that is 2 comma 2 comma 2 comma 0. We check here, low will be here, high will be here, and we'll write the indexes of it, and we'll store the mid value here. So now low is 0 and high is 3 and divided by 2. So we'll get 1. So now the mid is standing at mid, sorry, the mid is standing at index 1. The first thing what we are going to do is store store the value in a minimum variable. We are storing the minimum value in the variable min. So we have stored the min as 2. In the previous question, while we are solving, we are directly storing the nums of low or nums of mid because that will be always the minimum. But here I will be explaining an edge case later why we are taking the why we are taking the min value at the start instead of checking the condition and doing it. So the first condition what we'll be looking is if nums of low is less than nums of mid. So in this case, what we can do is if nums of low is less than nums of mid, we can directly check the compare the minimum variable with nums of low. Nums of low. Then what we are going to do? We need not to find anything at the left side because we already found the min element at the 0 index. So there is a guaranteed that whatever the numbers after 2 will be always equal or greater than. For example, if you take 1, 2, 3, 4 and 0 and 1, if you check nums of low is here and nums of mid is here. If you draw a graph for this, the number will always be increasing and there is a sudden dip. So we can say that we have found the left side. We have found the left side min value. So what you can do is you need to check for the right side after mid. So what you can do is you can directly move low equal to mid plus 1. Then there is one more case. If nums of mid is if nums of mid is less than nums of low, what we are going to do is we will be taking the min is min of min comma nums of mid and we will be moving I equal to mid minus 1. For example, there will be a condition that is you'll be having 4 here, 5, 6 and 1, 2, 3 and 4. For example, you have got mid here and you got low here and you got high here. If you check nums of mid is less than nums of low. So we can directly say that nums of mid will always be minimum variable among all the numbers. If you check, uh, 4 is greater than 1, 5 is greater than 1, and 6 is greater than 1, and we can end here. So that's, it will be checking, and it will be moving to here this side, because we already found the lowest element at the right half of the array, so we need to check the left half of the array. The above the above condition, we are checking we are checking the left side, and we are checking the right side of the array. And there might be a condition where, uh, so I'll be rubbing this. You will be having 4, 5, 6, then 1, 2, 3, 4, 5, 6, 7, 8, so on. So for example, we have nums of low and we have nums of mid. If you check, low will be here and mid will be here. The nums of low is equal to nums of mid. In that case, what we are going to do, whenever we get a duplicate element at nums of low, nums of mid, or nums of high, we can directly say, you just low will be moving one pointer ahead. So low will be moving here. So this will be running the loop until low and high reaches the end. We will do a dry run now. If we take 2 comma 2 comma 2 comma 0 comma 1, so low will be here, high will be here. Low will be storing those values here, low, high, mid, and mid. Now low is at, I'll be writing the indexes as well. So low is at the index 0 and high is at the index 4, and the mid will be 2. So the mid value 2. So I told you to write, to always check whenever you get a value, you always check the mid first. So now minimum will be 2. I'll be explaining why we took the min at the start by using one edge case. So for that I'll be just edge case. I'll be explaining that edge case next. So we got minimum as 2. So what we are going to do now, we know that low, if nums of low, we'll be checking whether nums of low is less than nums of mid. So this condition falls, then this condition falls, then we will be moving this pointer just one element before it. Now we will be updating the low, high, and values. So low is at 1, high is at 4. The mid value will be once again 2. So you'll be standing at 2, that is mid. Now you will be finding whether this mid is less than min. No, it's not. So we'll be keeping 2 as well. Then it will be checking whether nums of low is less than nums of mid. No, it's not. It's equal. Then it will be checking once again with nums of mid is less than nums of low. No. Then it will be going into the else block, and it will be moving the left pointer to one step ahead. Now low will be here. We'll be updating the low high values once again. Now low is at index 2, high is at index 4. Now mid will be 3. Mid will be at 3. Now we'll be checking if nums of low is less than nums of mid. No. Then there is one more case, that is if nums of mid, here it is 0 and nums of low is 2. So we can say that this condition is true, because if you check the nums of mid, it is 0 and nums of low is 2. 0 is less than 2, so this is pass. So now check the minimum variable. The min is 2. Now we got the nums of mid as 0. Here min is 2 and nums of mid is 0. 2 comma 0. Then the minimum value will be 0. So we need to update the minimum value, that is 0. Then we need to move to the left half of the array. So high will be moving here. Mid minus 1. Now low is at index 2, high is at index 2. Now the mid will be 2. But if you check the condition here, if nums of low is less than nums of mid, no. If nums of mid is less than nums of low, no. Then we need to execute this else block, that is low plus plus. So low will be moving ahead of high. So here we are breaking this condition, that is while low is less than or equal to high. That is the base condition of binary search. So low will be here, high will be here. So the condition is broken. Now we'll be returning the min variable. Min, that is nothing but 0. So in this array, the minimum variable is nothing but 0. I told that I'll be explaining the edge case. So the edge case is nothing but, we are stored, the first edge case is nothing but, we'll be storing the min by using min of min comma nums of mid, after finding the mid directly. Instead of checking here and here, we are also checking at the start. Do you know why? For example, you have got the value 1 and the index of it is 1. Now the low will be standing at 0, high will be standing at 0, and the mid you got is 0. For example, we just think that we didn't return this. We have not written in our code this statement. Now how our code will be behaving? We'll just check. See here, if nums of low is less than nums of mid, no. If nums of mid is less than nums of low, no. Then low will be moving to one pointer. So low will be standing at here. So min will be max underscore value. So here the base condition, that is low less than or equal to high, is broken, and we'll be returning the min variable. So if you check the min here, the min is nothing but max value, and the test case is failed. Now we will be checking with the real code which we have written where we handle this test case. So this is high and this is low. Low will be standing at 0, high will be standing at 0, mid will be standing at 0, and we'll be executing this line here. That is finding the min value by using min and nums of mid. So if you check the nums of mid here, the nums of mid is nothing but 0 and nums of mid is equal to 1 here. So the max, so in the min variable we are storing max underscore value. Now it is overridden by 1. Now we will be returning the min variable. Okay, then we'll be checking whether it is nums of low is less than nums of mid. No, then no, then it return, then it will be moving left pointer to 1 and left is becoming 1, and low should be less than or equal to high, but low is 1 and high is 0. So the base condition is broken here, and we'll be returning the min variable. So if you return the min variable, that is 1. I think the time complexity will be big of login, that is binary search, and the space complexity will be nothing but we have not used any extra space, that is O of 1. I think I have covered all the edge cases. Now we'll just code. I'll be moving to the laptop screen. I think the laptop screen is visible now. We'll be removing the previous code which we have written, and we'll be directly writing the binary search. That is nothing but we'll be taking low, we will be taking high, that is nums dot length minus 1, and we will be taking a variable for minimum where we will be storing the min value in the repeated set. This we will declare as integer dot max underscore value. Then while low is less than or equal to high, we'll be having the mid, low plus high minus low. We are using high minus low because if there are integer dot max underscore value and integer dot max underscore value, so whenever these add, they exceed, and we'll be getting the exception. So to avoid that exception, we are using low plus high minus low by 2. So we will be storing the min where this is the edge case we will be handling. The min of min comma nums of mid, single element edge case. Now we'll be checking if nums of low is less than nums of mid. If it is less than, then we'll be storing the min value, that is min equal to dot min comma nums of low. Then there is one more case, that is nums of mid is less than nums of low. If it's in this case, then we'll be taking the math dot min and checking min comma nums of mid. We need to write one more case, that is we have already checked the left side, so we need to move right side, that is low equal to mid plus 1. This condition is checking the right side, so now you need to move to the left side, that is high equal to mid minus 1. And there is one more case, if nums of low and nums of mid is equal, or nums of mid and nums of high is equal, then you just move the low pointer can directly return the link. Just a minute. Oh, I forgot to add semicolon. You can see that the test case are passed. We'll add one test case. It is, we'll check whether one is working or not. If they are given with one, yes, it is passing. We are good to go. Yeah, we have solved this question using the go of login, and this is a hard problem. Uh, that's it for today. If you like the video, please like and subscribe the channel. Have a great day.